Okay, Mark, Philip told me to wear yellow today. Why?
Right, so we're gonna do a little demo. So you're the sun, that's why you're wearing yellow, and I'm the earth, that's why I'm wearing blue and green, and this hula hoop is gonna represent the orbit, or the path that the satellites are gonna take around the earth. So we have to pay attention to a lot of things. One of them is the orientation relative to the earth, so that's this inclination, and then also the orientation relative to the sun. So as the earth moves around the sun throughout the year, it's possible that we could be facing away from the sun, we could be facing towards the sun, and for this mission, we want to be facing towards the sun the entire time. So we choose a sun synchronous orbit so that the twist of the orbit throughout the year is aligned with the Earth's rotation around the sun. So no matter where or when, we're always going to be in this orientation.
Gotcha. So I should always see every part of this orbit.
Yes.
Why is that important for the SPHEREx and Punch missions?
Sure. For SPHEREx, you can't look at the spacecraft without seeing this large cone on top. And that's because this is a photon shield designed to protect the sensitive instrumentation inside. And what it's sensitive to is to the sun. So with the sun always in this direction, that means we know the sun's never on this side. So that's the safe side. So that's when SPHEREx can go ahead and operate in the orbit in this direction, do their celestial sky observations, always working on this backside of the orbit, the safe side. Punch, on the other hand, is the exact opposite. It wants to study the sun. It wants to see the solar wind, the solar weather emanating from the sun coming to Earth. So this is a perfect orbit for them as they go around, because they'll go ahead and get maximum viewing time of the sun.
You know, we've been talking about in the broadcast how Punch is actually made up of 4 satellites, SPHEREx is 1. So basically you have 5 spacecraft that you're relatively, near each other as it's going around the Earth. How do you make sure that they don't interfere with one another?
Right, sure. Right. We do a couple things because you're right, that is very important. First thing is SPHEREx is going to go ahead and separate, pointing away from the sun, obviously, so they're going to separate in this direction. After SPHEREx separates, the Falcon's going to do a small altitude lowering maneuver with their attitude control thrusters, just to lower by a couple kilometers, so they're not exactly the same orbit. And then the Punch spacecraft are going to separate in different directions. So the first 2 Punch spacecraft are going to separate equal and opposite along the velocity vector. The other 2 canted off that vector. So that puts them all in different directions, even SPHEREx in different directions, keeping them all safely moving apart from one another.
Because SPHEREx doesn't want to be affected by the sun, can't be affected by the sun, were there special considerations on the ascent up?
Yeah, absolutely. Again, it's all about protecting the spacecraft and keeping the sun out of this top half. So what we're going to do is, normally we launch out of Vandenberg directly into the orbit plane, but instead we're going to launch east of the orbit plane we want to be in. That puts us on the dark side, or in the shadow, during those early phases of the mission. So as we then come out of shadow, we'll coast down to the South Pole, we'll circularize the orbit in a second burn, and also do a plane change to put us in that sun synchronous orbit plane we want to be in. So that keeps it safe for the spacecraft.
Guys, I know a lot of work and time went into, all these considerations that you just walked us through. I just really appreciate you guys taking the time to explain it so easily to us. Thank you so much.
You got it. Thank you.